Hello everyone, just audio check. Can you hear me? Awesome. Okay, so as promised at 12:30, thank you everyone. My name is Geoff Huntley, here today to run a brown bag on an operating system called NixOS. I had discovered this operating system through like word of mouth as I started learning more about Haskell, and it's not the most well-known operating system, but I actually think it represents some of the most cutting edge in operating system research. And it's not just academic, it actually has application. So NixOS is actually the backbone of AWS Cloud 9. So Cloud 9 is the IDE that you use for software development in your web browser. And when you log on to Cloud 9, you pop a web shell that's actually NixOS. So quick backstory and history here is I'm a software developer, but I wasn't always a software developer. I used to be in operations, and not just operations in the sense of like data center design, but actually all the way down to hardware repair. And there's quite a lot of old infrastructure out there. And I was fortunate enough to come across and maintain sysadmin, True64, AX, Solaris, FreeBSD, you name it. I've done a lot of operating systems, and I haven't been this excited about an operating system since I first did FreeBSD. And the thing that I found with NixOS that I find incredibly exciting is there are times when I've been doing work on a server and I cock it up, right? And I brick the server, and it literally means getting in the car and driving to the data center and fixing it. Luckily now we have remote boot agents, but it's still no easy way to roll back. Now this is where NixOS is absolutely brilliant. They've actually solved this solution. They've actually solved this, but to solve this, they've done some pretty interesting things. So I'm going to run you through NixOS and how it works internally, and compare it between, say, Ubuntu and how it is here. So while we're talking about data centers, I just want to quickly call out that bare metal hardware is insanely cheap these days. I have a server in Germany, and it costs me $100 a month. So it's about $1,000 a year. And this same server on Azure costs $14,000 a year. So just food for thought. Cloud isn't always cheaper. This is a 64 gig machine, 2 NVE drives, and a 8700 hexa-core CPU. Anyway, without any further delay, let's go through Nix. All right. So there hasn't been much in the way of, in my eyes, something that's exciting about operating system design in quite a while. The biggest advances we've had in operating system recently is really to do with how we manage our operating systems. Because the problem we have with operating system is state. Right? The way we normally manage a operating system is we log on to the machine, we modify the config by hand, and we mutate the state. And what happens is, over the years, we keep piling on these layers of state into the operating system. And it turned out, what it created was these pets. And operations teams became very, very scared to sysadmin these machines because they don't know how it worked. And this was the basis behind the DevOps movement of pets versus cattle. And the idea of a pet is where you've got a machine that's, say, 10 years old, and they've just done updates over the years. And cattle is the idea is, well, instead of naming it as a pet, just treat it like cattle, right? And just destroy it. Have immutable operating systems. And the tools used to actually do these immutable operating systems is they use something like Chef, Puppet, Ansible. And the problem with these tools is they're an abstraction on top of the operating system. They're not actually built into the operating system. And that's just really weird. And it means if your operations team modifies the config under the hood, and not the tool above, all of a sudden you now have a pet instead of a cattle. It's a problem. So NixOS solves this by actually putting desired state configuration in the operating system. So instead of actually having these external tools by the external vendors, it's actually built into the operating system. So I'm going to roll back a virtual machine here, and I'll run you through what NixOS looks when you first install it. Whilst that rolls back, I'm using a laptop that's a couple of years old today, so bear with me as we go through this. But the website for Nix is nixos.org, and it's what's called a purely functional Linux distribution. Purely functional. It's a little bit weird. The key word is actually down the bottom. It's declarative. It has the tools that you normally would bolt onto the operating system built into it. And the next key thing is the atomic upgrades and rollbacks. I'll be showing you how we do roll backwards and forwards in place. So nixos.org, when they talk about purely functional, they're looking from the idea of a function where you take two inputs and it always returns back the same result. There's no other state. So you pass in state into a function, it returns back. If you pass in the same input to A and B, same result every time. All right. Welcome to NixOS. So NixOS by default boots not to a graphical environment. It boots just to a console. So I provision a virtual machine here. I've booted to a virtual machine here, and it's got a hard drive connected to it. So the first thing you'll do with a brand new machine, bare metal machine, is partition it. So I'm just going to create a standard partition. We'll make it 500 meg. And this is where we're going to store our Grub, which is the bootloader, for a standard bootloader for Linux. All right, now create the second partition. And the second partition is for the operating system, where we're actually going to install the actual operating system. So quickly going to create the file systems. All right, so the file system is now initialized, so I've got to mount it. Okay, now this is pretty much vanilla Linux and Unix knowledge. Nothing else is different to how you normally would use Linux and Unix. This is where it takes like a massive curveball. This is where it becomes different. There's a bunch of commands in NixOS that allow you to bootstrap your operating system. With Debian, you use something called debstrap, and what that would do is essentially extracts a tarball. And that's what it's doing is it's extracting a known good state. The maintainers have cut a release of Debian or Ubuntu, and they're going, this is Wheezy. Right? This is Jesse. And it's of a known good state, and it just unzips the file. The thing is, where it's wrong by default is you've got that state. With Nix, it's different. See, with Nix, everything is driven by declarative configuration. Very similar to Puppet and Chef, but it's built into the operating system. So I'll show you the configuration. And it has a language called Nix. So NixOS is actually it's an operating system built on top of a package manager. And this package manager has some very special properties. I'll get to that later in the presentation. So if I want to make a small little change, say like install wget or vim or enable SSH, all I got to do is update the declarative configuration. And this will automatically go in and configure SSH as need be, and it'll store the packages that I declare. Now, once that's been configured, there's a command called NixOS install. And what that will do is it downloads the binary caches of the compilation. And you're going to hear me say the word binary caches a little bit because NixOS is actually a source-based distribution, very similar to Gentoo. But the problem with Gentoo, it takes a very long time to compile. Like I've seen a amount of time to compile. So what Nix, the package manager, does is it actually looks, because it's a purely functional package manager, it looks at the inputs, and if all the inputs are the same, then it goes, well, if I was to compile this, I'd get the same output. So why am I compiling this? So it generates what's called a binary cache. So when I run this installation, what's actually doing is it's looking at my declarative configuration and it's seeing that I'm using OpenSSH with the default configuration. And the default configuration that I use, well, the inputs are the same, so it can use the pre-compiled binaries. If I wanted to customize a special version of SSH with a particular version of PAM from source, that would compile that for me and save that binary artifact. And the cool thing about this is if you're working in a team, I can publish that binary artifact and share it between my team members. Now, that has limited value at the operating system level, but Nix is a package manager. You can use these same concepts to share CI artifacts. You can speed up your CI. So you can actually do source-based compilations at lightning speeds. So this one simple concept stacks all the way from the operating system down to the individual application. Because of the internet, I'm not actually going to run the install. I'm going to run back to a snapshot. All right, so it rolls back to the snapshot. What's occurring here is I've taken a snapshot just when I've done the install. And that's just when I've modified the declarative configuration and I've installed the packages. And the packages have been installed. And what I'm going to be doing is actually I'm going to reboot this virtual machine. And I'm just going to show something. There's something very, very special about what it does to Grub. Grub is the bootloader of Linux. All right, so yeah, NixOS install, you specify the root, which is the local mount point, and it's built. It's updated Grub, it's done it all for you automatically. So there's no longer you spelunking. What is the syntax for this, for Apache versus SSH and all that garbage? It's all been abstracted away from you. You just declare the intent of what you want. So I'm going to reboot this virtual machine, and I'm going to show you Grub. Grub is very, very special in NixOS. All right, so this is just a standard Grub menu. So this is the bootloader for Linux. There's two options here. There's the default, and there's also all configurations. So if you come from a Windows background, you might remember a boot option in Windows going boot from last known good configuration. The problem with boot from last known good configuration is only one configuration. With NixOS, every time you apply the configuration, it generates what's called a generation. And this generation is available in Grub, and you can boot back to that old configuration. So there are times in the last month where I've been playing with my server in Germany where I've bricked my machine pretty bad. and I've just rebooted it, pressed up, back up and running instantly. You can't do this with Debian or Ubuntu. You have to kill the server. You have to shoot the cattle. This is a really cool way of managing pets. Not everything can be containerized. There's a lot of software that's been made over the last 30 years that cannot be containerized. So I'm going to boot to the configuration, which is just the plain vanilla install. It's got OpenSSH installed. So as that boots up, I'm going to modify the configuration file and install Docker. And I'm going to use the default options, which means it's not going to need to compile from source. But I do have the option of making a derivative of this build and compiling from source. And that would compile once from source. And if input's the same always, it would no longer recompile every time because it has a binary cache. I could publish that to team members as a reminder. Just log in as root and password. And a quick tour of Nix. Some things are very different. Very, very different. Symlinks everywhere. Typical files that are read-write on Linux are now read-only. You cannot make changes to them. Like etc hosts, you cannot change them at all. To make the change to the config, you have to modify the Nix configuration and apply the configuration. So I'm going to install Docker and give you an example of this. All right, so here's the configuration. And if I had this configuration, it's very similar, like say ARM templates or something like that for Azure. It's like if I got this config, I can replicate this box immediately. I just like put it in, boot it up, pixie boot, done. There's a whole bunch of orchestration tools for NixOS called NixOS. And it plugs into bare metal providers of cloud, bare metal cloud providers around the world, also AWS and Azure. And if you've got this file, you can just bring your farm up, very similar to like Terraform. It's really cool. Anyway, so if I want to enable Docker here, I just go virtualization. And done. All right. I don't need to know how Docker works or how the configuration works. If I want to specify that Docker binds to a different network port, I can actually just go virtualization.docker.network interfaces, and then I can automatically create my bridge automatically. I don't need to know how Docker works because it's working at the right level of abstraction. Now, if I want to apply this configuration, there's a thing called NixOS rebuild switch. Actually, before we get there, there's a command called NixOS rebuild. And NixOS rebuild is very, very special. If you've ever done work on hardware, such as like routers and like network appliances, there's this notion of a T and a P firmware. One is a temporary side, one is a permanent side. And this is very common in Cisco routers. What you would do is you'll apply a configuration, but it's not permanent. So what happens is I can activate a configuration and test how it all works. And if it's no good, I just pull the power and it boots up to the last known good configuration. This is the principles of how all Cisco routers work. Likewise, NixOS rebuild, and that's called test. That allows me to test configuration. It activates configuration but doesn't apply it. There's options here that are insanely cool. I can actually specify a command line argument to actually spin up a virtual machine. So if I wanted to test my configuration without applying it, I just go like -- create virtual machine, and it will SSH into that virtual machine, and I can just poke around to see if that's exactly what I want. So you can actually do testing in production, but not on production. You can actually look at the changes between production and how it is. Just it automatically SSH in. You can either use QEMU or VirtualBox. Cool. Now, to actually permanently apply it, that's NixOS rebuild switch. Switch applies, switch activates and applies, and it creates a generation in Grub. So rather than activating, I'm just going to go to a snapshot. That way we're not waiting for it to download. And this snapshot is where I've installed Docker. Docker's been installed. So the command line tool of Docker, the CLI tool of Docker, is now going to be available to me. And when it becomes available, what I'm going to do is I'm going to roll back. Let's say I've just done a NixOS rebuild test or switch, and I've got reports from my user base that no, this is causing production errors. Instead of having to reboot the machine or all that stuff, I can actually do NixOS rebuild minus rollback, and that rolls back to the previous generation of last known good configuration. And I can keep doing rollback until the topmost thing when I first installed the operating system. Insanely cool. All right, we're done. Docker is now available. All I've done is applied and switched the configuration, but NixOS rebuild, switch. I'm now rolling back my configuration to the configuration without Docker. And what this is doing is it actually uninstalls Docker and any of the configuration. It actually cleans up the file system. It's no longer there. It's absolutely amazing. So if I run Docker now, it's missing. If I do NixOS if I reapply the configuration, because my configuration says I must have Docker, and I'm just going to activate it, not apply, it's actually going to go through and it's running the functions. The function says I'm using the default configuration of Docker, no custom source compilation, and it's going to use the binary cache. And in this case, welcome back Docker. No compilation needed, but if I needed to compile, it would have been automatic. So each step when I did this, it updated Grub with the configuration. I can roll back generations. It's a little bit of magic. I'm not going to reboot to show you how, to show the Grub. Just trust me that it's there. It's modifying Grub, and I can roll back without having to reboot. I'd like to quickly show you how this works. It's just freaking magic. It's so weird. First up first is, for the longest time, we've had this thing called the Unix standard, the Unix file system standard. And the idea is user bin bash, user local, var. That doesn't exist here. It's really, really cool. If I do which bash, it's under var current system swbin bash, but it's not really there. If I do a ps to show the listing of processes on the operating system, so I'm doing a listing of processes running the operating system, and what I'm seeing here is my SSH server. Now in the bottom right hand corner, you'll see this thing called nixstore, and then there's this hash, and there's this hash. So what happens is when I install a package, it's actually compiling that package while installing that package, and it's like chrooted. Or sorry, chroot is the wrong word because it has very particular meanings in Linux. But all the dependencies are within that folder. They're not globally installed. They're installed within a folder. And this is what allows side-by-side installs. This is what allows instant rollbacks. So if I upgrade to one version of SSH and I want to roll back to one version, well, I'm going to have multiple copies in the Nix store. And this leads us to the next thing. The Nix store has a garbage collector. Because as you compile and apply configurations, it's just going to keep installing. If the inputs don't match, it's a new generation, a new copy on the file system. And that will age. So it has a garbage collector that expires these old generations, these old applications from the operating system. Really, really cool. Now, this is the genius behind NixOS, is it's throwing out the file system standard. The file system standard is the thing that means you have to use sudo. Normally when you're on the Debian and Ubuntu box, you have to do sudo install Python. Right? You need admin access to install Python. And the reason you need admin access is because it gets installed into the Unix standard locations. By installing into Nix store, and like this, we can allow users without root access to install anything they like that they would normally need sudo access to install. Now this is really, really important because there's this notion called FFI. And this is a huge bane. This is a huge annoyance in the world of software. Foreign function interface is its proper name, but you might just know it as I'm compiling Python, but I need a particular version of ImageMagick installed. I need a particular version of NumPy with this C extension. Anytime you bridge, say, from Python to a C extension, that's a foreign function interface. And with Python, keeping the example of Python, you have virtualenv. And virtualenv allows you to install multiple versions of Python side by side, but that collapses as soon as you need to have different versions of ImageMagick or different versions of NumPy or different versions of OpenSSL installed. You can't do it. With Nix, you can. When you build the derivative, you just say, I want Python 3.5 with this version of NumPy, and it installs it all into a single folder in the Nix store. And when you're using it, you get that. And you can do that as a normal user without root. And this is what allows side-by-side installation. And what's insanely cool about here, we're moving into the layers of a past operating system into user-based territory, user land, runtime. And the applications, these binary artifacts that you're installing, say you install install Python 2.7 and Python 3.5, and it's custom to your application. Well, those artifacts have been generated from a CI server, and those artifacts can be used to just install. So if you want to install the application, you add in the reference to the binary artifact, and you just install it, and installation is immediate. And this allows you to do some really cool things, because symlinks have some interesting properties where they don't do file locking. You ever had a problem where it says open, you can't do this because file is open? That doesn't exist with symlinks. Symlinks allow atomic replacement without file handles and replacement of file handles. So there are companies that use NixOS specifically for this in their DevOps pipeline. They haven't gone full Docker. They've got an easy way of just switch, apply the configuration. And when they apply the configuration, it's like an instant apply, and they're coming from a binary cache. And CacheX was launched recently, and it's kind of like a cache as a service. But you can run your own cache internally within your organization, and you have your CI server pointing towards it. And this is really important if you're doing some pull request workflow on a Unix, because what you could have is you could publish the build result of that. You publish the build result of the pull request. So when you're doing your code review and you want to run it locally, you don't have to wait 10 minutes for it to compile. You just like 30 seconds, like 10, 15 seconds, done, install. Binary there, test it, done. So it enables source-based, source based software development to run at the speed of, say, people used to with Node, with binary, which is dynamic, like hot reloading, stuff like that. You start to get into these territories. So when people say that source-based compiling from source is terrible, no, it's not. The tooling is terrible. NixOS solves this, and there's a product out of Google called Bazel Build. Also solves this. Really, really cool. Used by Google, Amazon, and a few other companies. Anyway, I'm mindful of the time. It's been 20 minutes, been 30 minutes. I'd like to just end this and show you my configuration. So if you want to try NixOS, I've open sourced all the configurations for all my computers at home, everything from a Lenovo laptop to computers, a bare metal server in Germany, to running on a MacBook Air 2011. And this shows how you can lay out your configuration so you can do code sharing. So in this case here, we have a users, and I've defined that on all my computers, no matter what, I always want a username of G. Huntley. And this will create the user of G. Huntley, and it'll also on line 27 install the SSH key. And if I want to just synchronize this, I just update the configuration. I've got infrastructure as code. I just do make, and like I use like parallel SSH to the machines, or as a boot script, I pull and apply, and yeah, all my computers at home just work like this. It's amazing. Final remark is coming soon. On Sunday night, I got Nix running on Windows under Windows subsystem for Linux. I'm waiting for Microsoft to give the approval, but this will soon be in the Windows App Store alongside Ubuntu. So you'll be able to run it on your computer. And this is going to be essentially really, really cool, because this is the bridge that's going to allow a lot of people from the Haskell ecosystem or other ecosystems to learn it. If they've got a Windows computer, they can just quickly in that, and it's the easiest way to get up to speed. Thank you.